In late 2022, early 2023, we realized that our air conditioning in the middle building, the only building that's air conditioned right now, was failing. And we have a large facility, and we don't want to lose that community asset because we can't heat and cool it. So we, as a vestry, which is our governing body, decided that we would figure out how do we replace that system. In the process of doing that, we contracted with an engineer to come in and help us to understand our system. As we went through the various steps, we also were exploring what other possibilities might there be for our entire facility, which is 4 buildings that are tied together. And the engineer actually recommended geothermal to us for a couple of reasons.
We're seeing a lot of demand for this as it's a clean energy technology that's supporting the electrification of the system. There's other things like tax credits that are incentivizing this work and helping kind of accelerate our goals for electrification.
So the real tipping point was the Inflation Reduction Act, which passed 2022 and basically changed the commercial landscape from a 10% federal tax credit to a tax credit that is 30, 40, or 50%, depending on the eligible credits. A geothermal system after the federal tax credit and the kind of clean heat incentive ends up being about the same cost after incentives for a technology that's going to cost them less to operate, have less peak demand on the electric grid, and have no outside compressors and noise and everything else.
It's unique because it's an existing, rather old building, a retrofit, and a good example of the way this kind of technology can be used for things that already exist. So you don't necessarily need to have a brand new building to put in this brand new type of system. In our case, we're taking that heat, pulling it out of the space, squeezing it into a stream of water, which we then pump into the ground to do heat exchange with. What makes the geothermal system special is that we are storing that heat underground. We're warming up the ground all summer long. And then in the wintertime, we run our system in reverse and use that exact same heat pump to pull all that heat back out of the ground and heat our building.
Some of the challenges here is we're dealing with a constrained site, so we have to fit the capacity of the bore field in a small footprint. So we had to kind of employ a deeper borehole than we traditionally do, excess of 1,000 feet here. We also looked at some kind of more innovative approaches where we're drilling on an angle under existing building that's over 100 years old, all while not disturbing any of the footprint.
In particular, in New York, we've done a ton of these. It's different variations of a very similar challenge, where in a perfect world, you would be drilling all of your boreholes, underneath a wide open parking lot with all kinds of space and nobody in the way. But in a city like New York, that's just not a thing you have. In this case, we're drilling under the foundation while the building is still there, going at an angle from the side.
CDM Smith, we're able to bring kind of a multifaceted approach where we have engineers in all disciplines, from geotechnical like myself to environmental if we're working on a contaminated site, to mechanical, to site civil where we're helped to do any layouts, and even architects to help design some of these structures that you have to build, like a pump house or any pumping structures that may exist on the project.
There's so many different opportunities when we can use our building 12 months of the year, all the time. There's just too many more opportunities for us to be dreaming about how do we serve not only our church community, but also our neighborhood, because that's what we're here for, is to be a place for everybody in the neighborhood to enjoy and appreciate.